Okay, get out your notebooks. Today's lesson is 11.3, the distance and midpoint formulas. In your notebook, please copy down this formula for the distance formula, which is D, which stands for distance, and it is x2 minus x1, so you subtract your x coordinates and then square them, and then you're going to subtract your y coordinates and square them, add them together, and then take the square root. Let's look at this example here. The first thing I like to do is label my points. So I'm going to call this x1, y1 because that's the first coordinate that I have in the problem, and I'm going to call this x2, y2 because it's the second coordinate that I have in the problem. So the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm just going to plug the numbers into the formula. So the distance is equal to x2, which is 1 minus 3 squared. Oh, not 3. I need to be careful, that's why I should probably draw arrows. 1 minus 6 squared plus, and then I'm going to subtract 3 from 9. So then I have 9 minus 3 squared. So I find the difference. So this is negative 5 squared plus 6 squared, which is equal to 25 plus 36. 25 plus 36 is 61, and the square root of 61, I'm going to have to get my calculator out, is approximately 7.8. So the distance between these 2 points here is 7.8 units. I want you to try this one on your own and round the distance to the nearest tenth. When you have finished the problem, turn back on the video and we'll go over this together. So here's the distance formula. x2 minus x1, and then we're going to square it, plus y2 minus y1. Whoop, I don't know why I put that up there. y2 minus y1, and then we're going to square that. Add them together and take the square root. So I am going to call this x1, y1, and then this x2, y2. So now I'm going to subtract 4 minus 8. Oh, I have to do the x's first. 2 minus 3. It doesn't really matter what you do first because you're just going to add them together. And then 4 minus 8, and you can square that. So we have negative 1 squared plus negative 4 squared, which is equal to 1 plus 16. Which is the square root of 17, and the square root of 17 is 4.1. So the distance between those 2 points above is 4.1 units. All right, this one's a little harder. We want to find the perimeter around this quadrilateral. Now it's not a parallelogram, so opposite sides are not going to be the same length. So we need to find the distance from A to D, D to C, C to B, and B to A. So let's go ahead and use our distance formula. So first we'll find the distance from A to D. So we're going to find the distance of this line right here. So I'm going to label this x1, y1, and I'm going to label this x2, y2, and I will subtract them. So it's going to be 3 minus 0 squared plus 3 minus negative 1 squared. So that minus negative becomes a positive. So the distance of AD is 3 squared plus 4 squared, which is equal to 9 plus 16. That's 25, and the square root of 25 is 5. So this distance here is 5 units. Now let's find the distance from D to C. So I'm going to label this DC, the distance. The square root of, I'm going to call this x1, y1. So we'll subtract 3 minus 9 and square it, plus 3 minus 4, and we'll square that. So we have negative 6 squared plus negative 1 squared. Negative 6 squared is 36, negative 1 squared is 1. So we have the square root of 37, which is equal to 6.1. So this distance here is 6.1 units. Now let's find the distance from C to B. So we have the square root of, we're going to call this x2, y2. So we have 8 minus 9 squared. So we're subtracting these here, and then we're going to do 0 minus 4 squared. So we have negative 1 squared plus negative 4 squared, and that's equal to 1 plus 16. The square root is 17, which I think we just did on the last problem, and that is 4.1. So this distance here is 4.1. Now we just have the last side, and that's AB. So the distance of AB, we're going to do 8 minus 0 squared plus 0 minus negative 1 squared, which becomes plus a positive. So we have 8 squared plus 1 squared. 8 squared is 64 plus 1. So we have the square root of 65, which is going to be a little bit bigger than 8, and that's 8.1. So now if we want to know the distance around, we have to add all the side lengths together. So we have 5, 6.1, 4.1, and 8.1. Add those together, and we get 23.3 is the perimeter around that quadrilateral. All right, the next formula that we're going to talk about today is the midpoint formula. And here is the formula for that. You need to make sure you copy that in your notes. And what the midpoint is the halfway point between the 2 points on the graph. So this here would be the halfway point between those 2 points if you connected them together with a line. The formula for that is you add the 2 x's together and divide by 2, add the 2 y's together and divide by 2, and that gives you your midpoint. We should have some parentheses around here, and we're going to find the midpoint of between these 2 points, G and H. So I'm going to call this x1, y1, and I'm going to call this x2, y2, and it doesn't matter which one you call x1, what point is the first one and which one is the second one. So to find the midpoint, we are going to add the x's, which are negative 3 plus 7, and divide that by 2. And then we're going to add the y's, which is 2 plus negative 2, and we're going to divide that by 2. So we have 4 divided by 2 and 0 divided by 2. So the midpoint is equal to 2, 0. Now we can check this on our graph. Does that seem like the midpoint we move over to and up 0? Yes, that seems like the halfway point between the 2 points. Okay, why don't you try, not with your elbow partner, but by yourself, try this problem and see what you get, and then when you're done, turn the video back on and we'll go over this together. Okay, so here's the midpoint. We're going to add the x's together. Well, this one isn't as nice as the first example I went over with you because they don't label the points. So we better do that right now. So this is 2, 3, and this point is negative 4, negative 2. So we're going to add the x's together. So we're going to add x in negative, or 2 and negative 4. 2 plus negative 4 and divide it by 2. And then we're going to add 3 and negative 2. 3 plus negative 2, and we're going to divide that by 2. So the midpoint is negative 2 divided by 2 and 1 divided by 2. So the midpoint then is negative 1, and I'm just going to keep the other one as a fraction, 1/2. Oh, don't forget the parentheses. So let's check and see. If we go to the left 1 and up 1/2, that is the midpoint, and that looks like the midpoint of that line. Well, we're all done for today. If you have any questions, jot them down and bring them to class tomorrow. Thanks.